good morning or good afternoon or good evening, wherever you are. So now we are ready to start the final pitch session for the set week. I hope you've enjoyed the set week so far. I mean, this morning there was also some interesting talks from the Swedish Energy Agency, of course, and now there's a few other sessions, but we're here for the pitch sessions, which is also going to be very exciting. So please feel free to use the chat function on the right-hand side if you have any questions for these startups. And also for the startups themselves, please, if you're not pitching, please leave your mic off and only turn it on when it's your turn to pitch. My name is Laurence Green. I'm a project manager at the Deutsche Energieagentur, the German energy agency here. And I was formerly also a part of the set team last year. I'm still kind of like a part-time member, and I definitely didn't want to miss out on this year, even though we had to change it up a bit, but it worked out quite well, and I hope everyone has enjoyed it, and we can definitely take some of these experiences and make set even bigger and better for the next years to come. So without further ado, I think let's start perhaps a little bit earlier so we can save some time and have more time for questions. So I would like to introduce the first startup, and I think it's, if I say it right, it's Cliaspin from France. So I'd ask if Jean-Marc Coulon would like to begin with his pitch.
Okay, let's start.
Sure.
So I am Jean-Marc Coulon, and I will present you Thermosolar. So let's start. Energy transition should be our focus. However, I need to warn you. Many initiatives are moving from a polluting oil economy to a polluting green economy. It is the new green marketing and sales, giving most people peace of mind or good conscience, but still destroying the planet. On the first day, Andreas Kuhlmann talked about the Tesla factory in Berlin, which will consume energy like Leipzig. What is the benefit? Remember, studies have shown that the Tesla car need to drive so much kilometers to be green that most of them will just be as bad as fuel car. So wrong problem, wrong solution. Another example is CO2 trading. Its impact balance, if we are honest, is zero. What you gain is what you destroy. So in fact, it's a financial capitalism to make money while giving authorization to pollute. Wrong problem, wrong solution. So the biggest problem of energy transition is the constant growth of energy consumption. Whatever effort in renewable energy we achieve, we still need to increase the production of coal, gas, and oil every year. The main contributions to this problem are maritime transport and materials, mainly cement and heavy metals, along with aluminum and steel. By moving from lithium electric batteries to thermal batteries, we reduce heavy metal use and solve the recycling issue of the batteries. We have a solar and biomass energy source, which gives the opportunity to have a real clean solution for every day. We do not import PV. We produce everything locally. So we propose no pollution energy production. Application of our technology. We have one engaged prospect in Morocco, an olive oil extraction company, which need hot water and electricity. Other usage include eco-resort in Madeira and in Spa in Belgium. We have also hemp fiber extraction, hospital, etc. In fact, many businesses need both electricity and heat, which we fulfill with our cogeneration principle. So We just gained a research contract with ESA, the space agency, to create a demonstrator. We were also finalists of the Climate Launchpad competition. Today, we seek seed capital to accelerate our market product introduction. And guess what? Our next spin-out will be about disrupting construction method. Remember to tackle the real problem with the real solution. Thank you.
Okay, thank you for the first pitch. Very interesting. Now, I just asked the attendees, does anybody have any questions for Jean-Marc here? Please remember to ask in the chat. If you don't have any questions now, we can, of course, you can still write them in the chat and maybe we can address them later. Yeah, but addressing the real problem, right, with the right solution is very important, especially in these times with Corona, with green recovery. But yeah, thank you. So if we don't have any questions, we could move forward. And let me introduce the next startup. We have Mango Solar from Germany. So Rebecca Bregant, if I say that right.
Yes.
Yeah, thank you. We can hear you okay. So we have 12:06. So let's hear your pitch. Thanks. You can start.
Thank you, Laurence. Happy to be here.
Sure.
So hi everyone, I'm Rebecca, one of the co-founders of Mango Solar, and I'd like to take you on a journey to Africa. So what does Mango Solar do in Africa? Actually, it's not about growing or eating mangoes, but we focus on the solar part. So we accelerate solar electrification in Africa using a tailored software solution. So for who are we doing this? Our main target group are local distributors in Africa who bring solar energy to the rural population. The problem is 600 million people still don't have access to electricity. So there's a lot of work to do, but the problem distributors have is they spend a lot of time and money on ordering solar systems and then selling those systems to the rural communities. So what does Mango Solar do to solve this problem? We've developed a software tool that is tailored to the needs of solar distributors. It means that the tool digitizes their processes and scales their business in the so-called last mile field. So we offer like a digital assistant for the distributors so they can manage their supply chain and their sales force in the field. How can our software do this? First of all, it flexibly adapts to the distributor's needs with features that are 100% customizable. Also, our software is made for Africa, which means on the one hand, it offers online features like mobile money payments, which is very widespread in many African markets. And on the other hand, our software offers offline features because in some remote areas, for sure, there's no internet at all. And also our software comes with a low barrier pricing, so it's really accessible to all kinds of distributors. And finally, our software finds new selling opportunities using AI-based analysis. So why should distributors actually pay for our software? What value is in there for them? First of all, they can reach a lot more customers faster and better, at the same time save time and costs, and consequently accelerate their solar business. At the end of the day, accelerating businesses is not everything, for sure. For us at Mango Solar, it is important that we make a scalable impact on people and the planet. Because as we all know, access to clean and affordable energy is number 7 of the Sustainable Development Goals by the UN. So this is what Mango Solar does, what drives us. If you would like to find out more, feel free to visit our website, drop us an email, or just ask me some questions right now. Thank you.
Thank you, Rebecca. Thanks for the pitch. Sounds really interesting. I have a quick question. Is it subscription based, or do the distributors have to pay a percentage of their sales using the tools? Probably not. So what's the basic business model there?
So we have a software as a service business model.
Okay.
We have subscriptions. It's like a basic module, basic functionalities. And in addition, we also have quantity-based plans based on how much they sell.
Mm-hmm.
So it's really accessible also for small distributors who don't have huge revenues yet.
Okay, cool. And another question, I guess, how many distributors? I mean, Africa is massive, and perhaps you can't answer this, but what's the sort of market like there for distributors of solar solutions?
Well, so we have in total 1 billion people that have no access to electricity. In Africa, it's still around 600 million. So, and right now they spend a lot of money on kerosene, so on the end customer side. It's for instance, for Kenya, it's $15 per month per household, which is quite a lot of money. So yeah, and how many distributors there are, that's really hard to say. So yeah, I think based on how many people that are not electrified, there are many distributors, and yeah, we have some pilot projects with 3 distributors right now at the moment, and so we really make sure that the software is being co-developed and tailored to their needs.
Okay, cool, thanks. I see there's some other questions in the chat from Taha, and Taha asked, what is your current funding stage, Rebecca, or Mango Solar?
Yeah. Yeah, so we've raised grants from the German government so far, around 300,000 euros since 2018. And right now we're in seed stage, so we're seeking capital of 200,000 euros. So we can further develop the software, really get into the market launch, spend a lot of budget on marketing and sales for sure.
Okay, thanks. So if anyone wants to get in touch with Rebecca, you can of course use the chat and the networking function. And I'm sure as on the slide there, you can reach out to Mango Solar as well. Cool. So thanks again. And let's see, there's no other questions. Thank you, Rebecca. So let's move on to the next sort of pitch, which is, I have before me, Sagar Energy Solutions from Tanzania. And we have Andreas Ostrovsky Pereira. Yeah, so if you're ready, Andreas, the floor is yours. And for everyone else listening, please mute your chat mute your mic if you're not speaking, and feel free to use the chat functions there if you have any questions. So, Andreas, you're good to go.
Thanks. Good afternoon, everyone. Can you hear me? Can I get a quick thumbs up if my sound is okay? Perfect. Well, good afternoon, everyone. My name is Andreas. I'm the co-founder of Sagar Energy Solutions. And we're an access to energy startup from Tanzania, where we develop productive load appliances to replace old, outdated, and unsustainable methods to directly increase incomes and not just make access to energy cheaper. Because we believe that is the key in the entire energy loop in order to achieve the impact that we all really desire. So our approach is looking at entire value chains and identifying areas where we can have an immediate impact. We have identified the fishing industry of East Africa as being incredibly productive, yet it's still dependent on unsustainable practices. And that's why our first product focuses on the very step of the value chain, which is the actual fishing. We've developed a solar-powered fishing lamp, which replaces the commonly used pressurized kerosene lanterns to attract sardines. Now, I'm sure we all know Lake Victoria as being the world's second largest freshwater lake, but more importantly, over half of the fish consumed in all of Africa comes from this very lake. And over half of the total yearly catch of this lake is this small sardine. So it's important to understand that this night fishing industry provides jobs and food for millions and millions of people. And kerosene is bad. We all know this. It's been heavily researched and proven. It was mentioned earlier. And a lot of these remote communities and industries, they still are being overlooked, and they still are suffering the consequences. Almost $2.5 billion are spent on kerosene on the lake every year, which in populations where the majority earn between $1 and $3 a day is a lot of money. And the environmental impact is also huge. Almost 500,000 tons of CO2 are emitted every year from the lake alone. So we're in a very unique position because our product and its productive aspect is very sought for, not just from our customers and end users, but also it's highly attractive to solar home system companies and mini-grid companies. So we have very clear and straightforward business models. Our B2C model, our lamp is sold for $250 each, where our customers are normally fishing camp owners who own all the fishing equipment and employ the fishermen. Now these customers, they normally purchase between 24 and 56 lamps on average. So while these owners are improving their business operations, the fishermen also reap the benefits in terms of higher incomes at the end of the month. In our B2B model, our lamps sell for $200 to $220 each, where solar home system companies, they want to expand their product offering, and where mini-grid companies are desperately looking to increase their energy offtake, as the majority of the mini-grids that operate in these areas, they operate between 40 and 60% capacity. So we currently have about 1,200 outstanding purchase orders. We have 3 B2B pilots in the pipeline. We're planning the rollout of our next product, which is a fully sustainable and clean drying solution. So we are actively looking for working capital so that we can meet our demand and continue with our growth. So I'd be thrilled to link up with anyone who may be interested. And that's all from me. Thank you very much.
Thank you, Andreas. Sorry that we didn't get your slide up earlier, but now it's there. No problem. Pictures there. Yeah, does anyone have any questions for Andreas? I mean, I have a quick question, but maybe I'll leave that for some other people. So we have a question here from Manuel Goldman, who asked, where are you manufacturing your lamps?
So we're currently manufacturing in India, but most importantly, we're assembling in Tanzania. So we're developing a whole local assembly line. In the future, our goal is to actually build a manufacturing facility here. But for the time being, all we can do is assemble. So it's a partnership between India and Tanzania.
Okay, cool. And sorry, I'm not sure if you mentioned, but what is your, I guess, do you have a lot of competition there in this area? I mean, sure, there's a lot of solar lamps, but I think you were saying that you have specific focus. So maybe you could talk about that quickly.
Sure, we have some direct solar competitors, although none of which use specifically designed lamps or products to use for that specific function, so the fishing. And also the majority of the competition comes from local retrofits. I mean, the local fishermen, they realize that they're wasting the money on kerosene, so they're buying their own batteries, they're buying their own bulbs, retrofitting, and so on the day that might be cheaper, but over a long period of time, it's really not. So we're coming in at a really competitive price point with what we consider the best product.
Okay. And what's the sort of market? I think you also mentioned that you have many orders, but for this specific purpose, I guess, how do you see growth there?
So the interesting bit is that Lake Victoria is obviously the biggest body for night fishing because it encompasses Tanzania, Kenya, and Uganda. So that is the main market. It's about a $160 million market for us. But there's so many more water bodies that we're looking to expand to. In Tanzania itself, we have 2 or 3 different big lakes. We have the coast. We want to move down south to Mozambique, and even in Southeast Asia. So for this product specifically, there might be a cap eventually. But that's why I mentioned we look to target the entire value chain. So the next step is the drying solution. We're then looking at cooling facilities. So the lamp is kind of a way into the market to get people to know us and trust our tech.
Okay, cool. Thank you. Good. Then, sorry, we have another question just from Rebecca Brigant. What was the price of the lamp? I think
so B2C, it's $250. However, a lot of our customers, they, like I said, they are these big fishing camp owners. They are bankable. They tend to have access to finance themselves. So the majority of our customers, they do get some kind of financing, which makes it cheaper from day one compared to kerosene.
Right. Cool. Okay. Thank you. Good. Then thanks, Andreas. So for anyone that wants to reach out, the contact is there on the slide, I see, and there's also the chat function and the networking function within the hopping tool, which we're using for Set Week here. Cool. Okay, so let's move on to the next pitch because we're on time. It's looking okay. Cool. So now we have INERATEC GmbH or GmbH from Germany. So I'd like to invite Philipp Engelkamp to take the stage. Actually, we see that Philipp is not here at the moment. So Hopefully he arrives later. Oh, yes, he is. Beg your pardon. What? But not on stage. Okay, so we'll have to shuffle the order up a bit because Philip's having a little bit of technical problems. So I would ask instead that Nowi from the Netherlands, if you're ready to go, that would be good. So Simon von der Yacht.
Yeah, I can go first. You guys have my slide up as well then?
Yep, I think they'll be coming just in a moment.
All right, I'll just get started then. So I'm Simon. I'm the CEO at Nowi, and we're working on very small problems compared to what most people are working on, I think, but it adds up. So what we are focusing on is the bottleneck, we think, in connecting the physical world to the digital world. So there are billions and billions of little devices, from the sensor that turns on the lights when you walk into an office room, to the thermostat in your house controlling the temperature, to your smartwatch on your wrist, that are all sort of connecting the physical world to the digital world, and it's making our world smarter. But there's also a big bottleneck in that really fulfilling its promise, and for us as society sort of reaping the benefits from that. And that's very simple, is that if we have all of these millions and millions of devices, then how are we going to power them? So traditionally what we've done is we say, well, we'll bring energy to the device. So I'll put energy in a battery and I'll bring that battery to the device, and that way I power the device, or I bring a cable to the device, for example. But fundamentally, at that scale, that becomes problematic. It is impossible to swap 1 million batteries from 1 million sensors spread out over a city, for example, that are monitoring the roads or the traffic, or something like that. More problematic, and this is, I think, where sort of the micro scale starts having a mega impact, is that it takes 50 times the energy to create a battery than the energy that it holds. So it's an extremely unsustainable way of powering devices. Then taking into account they're very, very difficult to recycle, and we end up throwing about 50 billion batteries a year on the landfill. This becomes really a big problem also on the mega scale. So what we fundamentally felt is that if it becomes impossible to bring energy to all of these devices, especially in a sustainable manner, then the only other alternative is to say, well, we'll have to use the energy that's already there at the location of its device. So we need to go from plug-and-play devices to plug-and-forget devices. A device that you can place there and it's essentially energy autonomous. It will power itself. So we do that by energy harvesting, by using little bits of energy from the environment to power the device. So this can be the light, in a room created from the lamps or from the outdoor windows. This can also be movement, vibrations, you name it. There's lots of little bits of energy all around us that we can use to power these devices. It might not be enough to power a laptop or a television, but these little remote sensoring devices, we can actually power with that. So we've developed the world's smallest energy harvesting chip, the most cost-effective energy harvesting chip, and the chip with the best performance. So we're offering that now to different product makers to integrate into their products, to make it very, very simple and cost-effective to implement this type of energy harvesting technology into your products. So we have about 8 patents on the technology. We've raised about $14 million overall, and we've now 4 years in of product development, and we're ready to collaborate with large companies and helping them design into their next generation products. That's my presentation. I don't know if there's any questions.
Yeah, so we had a bit of a problem with getting your slides up, but it should be able to see that now on my screen. Sorry for the delay. Yeah, so is there any questions for Simon? Thank you.
I see Steven, I think. So you've designed a chip? Yes, we have. So this is a power management chip that we've made that is completely optimized for efficient energy harvesting, but with a footprint that's about 30 times smaller than anything else that existed, and a bill of material cost that's about 95% lower than anything else that previously existed. Another question on potential applications. So that's quite diverse. So we do a lot of sensoring device applications. So from measuring conditions of roads in cities all the way to smartwatches. So with the Swiss watch manufacturer, we're working on a smartwatch that does not have to be charged anymore, whereas now it has to be charged every week or so. But also very simple things, television remote controls, where everybody's discarding 2 AAA batteries every year. We're now making those in a way where they essentially last indefinitely from a power point of view. So really anything where you put in a few AAA batteries is roughly in the ballpark of what you can do with energy harvesting. I'm sure if there's any other questions.
Yeah, thank you, Simon.
Yeah, see, one more. How much % of energy can your individual chips save? Depends a bit on the product, but in most cases, our aim is what we call plug and forget, right? Where after you place it, you essentially do not have to think about that anymore. And the only way that you can do that is if, from a power point of view, the device lasts longer, than any other factor. So at some point, anything will just break, but it won't break because it ran out of power. So for that, it essentially needs to be energy autonomous. So we harvest more energy in a day than the device consumes. And as soon as you sort of reach that tipping point of harvesting more energy in a day than you're consuming, essentially the device can last indefinitely from a power point of view.
Okay, thanks, Simon. There are a few more questions there, but we want to stay on schedule. We're about a minute behind, but I see now that Philip is in the room. So I'll invite, sorry, if anyone wants to reach out to Simon, of course, use the chat and the email there provided in the slide. So I'd like to invite Philip Engelkamp from INERATEC. The stage is yours when you're good to go. Oh, we can't hear you at the moment. No. Okay. We'll try to figure that out with the audio, and we'll move on to the next startup in the meantime. So let's invite Elestor from the Netherlands. Guido Lessi, if you'd like to start your presentation, I'll just get your slides up now.
Thank you very much. I hope I'm hearable. Dialing from the Netherlands, the beautiful city of Arnhem. My name is Guido Lessi. I'm CEO and one of the investors in the company Elestor, which stands for electricity storage. What we do is we have developed a new electricity storage technology, and I think by now everybody is convinced that this whole energy transition will not happen if we don't have electricity storage. The key factors of our technology are that it is for large scale, for stationary applications. It's very highly scalable because it's built in a modular design. So there's, from a technical point of view, no limitation on the size of the system. Patented worldwide and internationally awarded. And our mission with this system, I would almost say our obsession, is to target the lowest possible storage cost per megawatt hour. And the reason for that is obvious. Storage costs money per megawatt hour. The people who use our systems, they want to see a business case. They want to see a return on investment. Otherwise, this storage will not make sense. Then there is no impact, and then it will not accelerate the energy transition. So it's really imperative to have a business case, a viable business case around storage. Reaching these lowest possible storage cost per megawatt hour are based on a triple cost reduction strategy by first choosing a flow battery technology. That's like a family of batteries with different chemistries. And the chemistry that we choose is hydrogen and bromine. It's very cheap, it's abundantly available, and of course you can lose your advantage in costs if you don't design it smartly. And for that part we have a patent on the heart of the system. Actually, by using hydrogen, we also bridge the two worlds, battery storage and hydrogen storage, which seem to be two religions in the energy transition. The bottom line is that we want to turn storage from a pure cost factor into real viable business cases. Company exists since 2014. Was started by my colleague Wieband Kout. He is heading the technology development in the company. And in the past years, we did a handful of pilots on small scale, but in real situations. We are currently building 4 pre-production systems on actual scale. So that's container size, as you can see, prior to launching the technology commercially. And that will be done next year. First deals have been signed, and our dot on the horizon is to build the gigafactory equivalent for hydrogen bromine flow batteries. And lastly, if you wonder why I used a background of the sea, that is where the bromine comes from in astronomic quantities. Thank you very much. Any questions, please?
Okay, thank you. I see that there's a question there. Thanks for the pitch and thanks for sticking to the time. So we have a question from Stephen, and he says, where do you think the key boundaries lie between electrical and hydrogen storage?
Yeah, that's an ongoing discussion. Some people need storage for just 1 hour, or to bridge 1 hour, some for days, and there are also people looking for seasonal storage. We think that other technologies like lithium and flywheel are fit to provide solutions for short-term storage. We start at storage covering 5 to 10 hours up to maybe a couple of days, 3-4 days. If you want to go to seasonal storage, it makes more sense to look for power to gas solutions like making hydrogen with electricity. Yep.
Okay, thank you. Let's see, is there any questions there? We have a question from Carsten here. It says, what is the environmental impact of bromine hydrogen storage compared to current technologies?
Yeah, really good question. Bromine is a natural element. It comes from the sea, as I noticed. It can also, at the end of life of a battery, it can be dismantled and the whole bromine and hydrogen volume can be reused again. Bromine has a big application as a fire retarder in fabrics. So it's not such a well-known element, but it's widely used. So the environmental impact of using this chemistry is actually extremely low. It can be 100% recycled.
Okay, thank you, Guido. So if anyone has any more questions, feel free to reach out. And now, in the sake of time, let's move on to the next startup. I just want to check, Philip, can we hear you? Can you please? Oh, sounds like it can. No, unfortunately not. So I will just check with Tahar and he'll try to figure out how to get you with your mic on so we can actually hear. So let's move on to, we have Aperitas, I think. Aperitas from the Netherlands. And I would ask if Michael Boricius, sorry, would like to start the pitch there.
Yeah. Thanks, Laurence. Yeah, I don't have the easiest name.
No,
I'm aware of that.
Actually.
Sorry for that.
Okay.
All right. So thank you for having me. I'm indeed Michael from Asparatus. We're enabling data centers to be future-ready, sustainable, and energy neutral anywhere. Data centers need a lot of power, space, and cooling, and next generation's IT hardware are close to impossible to cool efficiently with air. And this results in data centers becoming hyperscale for efficiency, only being located in colder climates, and actually very complex to build, resulting in high costs, inflexibility, and a lot of wasted energy as well. Emerging digital technologies should be facilitated anywhere to support research, development, economic activities, and our digital societies as a whole. We can make data centers simple, sustainable, and small. So today, most data centers are being cooled with air, and we are replacing the cooling medium air with liquid in a way so that the data center becomes a plug-and-play solution. Technically, we immerse hardware in a dielectric fluid developed in partnership with Shell for efficient cooling, resulting in a fully contained solution that can run anywhere as long as there is power and data connectivity. This is called immersion cooling. Currently, this solution has been selected by telecom providers, banks, universities, cloud providers, and large enterprises in Europe and beyond for its ability to reduce data center costs, increase compute performance, and sustainability. So what's really unique about the technology we have developed and brought to the market, actually we brought it to the market in 2017, is that we can operate it with warm water cooling in hot climate zones. So that means that we can run data centers in deserts or hot and humid cities like Bangkok or Singapore in the same way as we do in the north of Sweden or Iceland. At the same time, we can also turn all the used electricity, which is a lot in most cases for data centers, into a thermal energy, basically hot water of 60 degrees Celsius, for example, fully ready for reuse. And this data center heat is now in high demand in urban areas like Amsterdam, London, Frankfurt, Copenhagen, and Stockholm. In 2018, we have won the New Energy Challenge organized by Shell, Yes Delft, and Rockstart. And since then, we have taken a leading role in the data center industry. Last year, the World Economic Forum selected our technology and our integrated immersion cooling solution with Shell as one of the energy breakthrough innovations introduced in the last 10 years. Sustainability is key in European data center hubs like Amsterdam, Frankfurt, and London, where the demand for data center heat is very much increasing, while at the same time, the fastest growth markets for data centers are in Asia and the Middle East, where the climate is very challenging to operate data centers efficiently. We can reduce the capital investment required for data centers to build one with at least 25% and reduce the operational cost with another 30 or up to 50%. Mostly reducing energy costs. With more than 7,000 commercial data centers globally, this is a great business and also a great impact opportunity. In 2019, we brought Shell Ventures and PDNH on board as investors. And as a team with an extensive data center, cloud and IT hardware background, we benefit a lot from their support. If you would like to work with us to make one of the fastest growing industries sustainable and future ready, as a customer, as a partner or investor, please reach out because this is the time. Thank you very much.
Thank you, Michael. Sorry about the problem with the slide again. We got it up. It seems to be a bit buggy at the moment. But yeah, thanks for the pitch. So we have a few questions there from Maurizio. It says, have you ever thought to electrical conversion of the heat?
Yes, of course, we have thought about it. That would be almost the holy grail, right? So at this moment, with our technology, we can run data centers close to energy neutral, especially when we reuse the heat, right? But electric conversion would be great. We work gladly together with partners working on that topic. It's not part of our core business model. We really limit ourselves to our core technology. But since the beginning of our foundation, we happily work together with both corporate startups and scale-ups actually to develop technologies that can have an impact on top of our technology, for example.
Okay, thank you. Do you have another question there? Yes, from Steve. Also, we're talking about small efficiencies here from Maurizio. Maybe we will ask the question from Steven here, who asks, what are the next key ambitions and steps for your business?
Right, yeah, so far we have focused a lot on Europe. The few of the largest data center markets are actually in Europe: Amsterdam, London, Paris, and Frankfurt. And at the moment, we're looking very much at, of course, growth markets like Asia, which is also a really good product market fit for us. So we're expanding in that direction as well in terms of market development, right?
Okay, thank you. Okay, so anyone interested to talk with Michael, please feel free to reach out, use the chat, and of course the networking function. So let's try again. Philip, can we hear you? Or still not? No, we still can't hear you. Perhaps check with your browser. Sometimes there might be a pop-up there which will ask if the application can use your microphone. You're nodding like you've tried it. Unfortunately, at the moment, I don't have any other ideas for you. I think Teresa and Taha said that they're talking to you in your chat, so maybe they have some ideas for you there. Yeah, Teresa has suggested perhaps try refreshing your browser, or if you're not already using it, use Chrome, I think was the idea, because there seems to be more issues, or it's a little bit buggier with Firefox. Yeah. Okay, so let's move on to our next pitch. which is Leyden-Jar, also from the Netherlands. Christian Ruud.
Thanks,
Right.
Laurence.
Cool.
So,
You.
can you hear me all? Absolutely good. So, first of all, very nice pitches by the other ventures, very interesting. So we're in the business of boosting the energy of battery cells. My name is Christian Rood. I'm the founder of Leyden-Jar Technologies. So these battery cells currently, they're just not good enough, right? And just imagine that if you have very good battery cells, it would mean that electric vehicles would drive much further, that electric flying could really take off, and that storage would become affordable. Now, this is something that we enable, and we do that by addressing the current bottleneck in battery cells. And that is the battery anode. We are replacing the traditional carbon-based anode by a unique pure silicon equivalent. And that means that we can produce much thinner anodes, and that lead to an energy density increase of 70%. And that is world's highest energy density in lithium-ion cells. We have demonstrated this last summer. It has been validated by DNVGL and by Bloomberg New Energy Finance. So we've demonstrated this in our own battery lab in Leiden, and also in our pilot line in Eindhoven, where we can make pure silicon anode rolls. And these rolls, these can be integrated in any existing battery plant for lithium-ion batteries, which means that there can be kind of an upgrade of gigafactories, and that is our strategy. These thin anodes do not only lead to a higher energy density, but they also lead to a reduction of 62% of the CO2 footprint and the NOx footprint. So the battery cell as such does not only stimulate electric driving and electric flying, but also the production of the battery cell can have much lower CO2 footprint. We're currently working with clients to apply our technology in prototype cells in specialty applications, consumer electronics, and automotive. And we're planning to do this a little bit on the longer term for residential energy storage as well. We're currently raising 15 million of equity. And we're doing that to establish a industrial platform. And with the industrial platform, we can do a ramp up to gigafactory level, which is of course a very massive application. We're also using this 50 million round to increase our battery infrastructure and to work with much more commercial projects, because we're currently kind of full with our existing organization. So very happy to discuss this in more detail with you, and also happy to take on your questions. Thank you.
Okay, thank you, Christian. Do we have any questions there? Yes, we see a question from Stephen. Lau says, do you plan to sell anodes to battery manufacturers, or do you plan to eventually manufacture batteries yourself?
Yeah, great question. So on the short term, we have this ability to produce anode rolls in Eindhoven. And that makes this technology very actionable. So it means in practice, we're already selling now anode sheets for sampling and for proof of concept projects. And we think for the specialty market, which could be e-flight, defense, medical robotics, we can sell these anode rolls to existing battery makers so that they can make cells. But once we are eligible for mass markets, which is consumer electronics and automotive, the scale is really enormous, right? This is gigafactory level. So our strategy then is to offer this production platform to battery makers so that they can introduce the technology into their gigafactory and they can make anode rolls themselves. And then our business model is a licensing business model.
Okay, thank you, Christian. We have another question there from Carsten, but in the interest well, interest of time, I'd rather prefer that we move on, and then maybe we can address other questions if we have some extra time at the end. So please feel free to reach out to Christian, of course, through the chat and other networking opportunities. So now let's move on to HydroPlat from Kazakhstan. Aidana Tolosova. Yeah, please feel free to pitch. Yeah, welcome.
Thank you, Laurence. Hi, thank you, Laurence. Hello, everybody. My name is Aidana, and I'm here to represent HydroPlat from Kazakhstan. So, if hydrogen cars do not produce any greenhouse gases, why aren't we driving hydrogen cars? This is because of the platinum group metals that is used in hydrogen cars in its fuel cells. Because the demand for platinum is also increasing by 18% and the reserves are getting less and less, it won't be enough for us to produce and replace all petroleum cars by hydrogen cars. And HydroPlat is the solution to making hydrogen cars more affordable and popular with the use of our electrocatalytic nanomaterials that are made out of biomass. We are going to sell our nanomaterials at 27 euros per kilowatt, and compared with other hydrogen car fuel cell and manufacturers, they would like to reduce the price by 50 to 30 euros per kilowatt, but we are already reducing the price to 27 euros per kilowatt. There are other catalysts that exist in the market other than platinum, like palladium, but because our nanomaterials are renewable, they are more sustainable. And once it is genetically modified, which I will get to later, we will just have to generate and grow our cyanobacteria to generate the nanomaterials. So how are our electrocatalytic nanomaterials made? We are going to genetically modify cyanobacteria, and it will reduce the sulfur from its surroundings, and then we will burn them in the furnaces, keep it in the furnaces, and then they will turn into charcoal like dark powder, which will have the characteristics of the platinum. And therefore, it can be used as a catalyst to replace the platinum group metals in the fuel cells. Analyzing the market of the fuel cells, we have come to conclude that there are no other biomass catalysts that are cheap as our nanomaterials. And also, the climate impact here is immense, because if we imagine that we can replace all petroleum cars with hydrogen cars with the use of our electrocatalytic nanomaterials, we will be able to reduce the carbon emissions from the transport industry. And in 2019, we were awarded the Clean Mobility Theme Award at the Climate Launchpad Global Grand Final. And if you would like to partner up, we are currently at the stage of seeking some investors and partnering with hydrogen fuel cell experts. Please don't hesitate to get in touch with me in LinkedIn. Thank you very much for listening.
Thank you, Aidana. Very interesting. Does anyone have any questions for Aidana? We have none in the chat just now. I have a question. What is the closest competitor that has also a